All right, find the roots of each function. So in number 5, in order to find the roots means x-intercepts, we know that the y value is equal to 0. Now the only way we can solve for x here is by factoring. So we need to think about, well, what type of factoring can we use? There is no greatest common factor here, so we can't take out a GCF. But we can recognize here that this is a difference of perfect squares. So we can factor it by looking at what's the square root of 16x squared. That's 4x. And we know that the square root of 25 is 5. The factorization of difference of squares gives you these two being added together, these two being subtracted from each other. So we have the zero product property, which tells us that either 4x plus 5 equals 0 or 4x minus 5 equals 0. So our roots are at negative 5/4 or positive 5/4. And let's write these as points. So the x-intercepts or the roots are at negative 5/4, 0, positive 5/4, 0. All right, let's also look at number 8. So again, the roots are the x-intercepts, so that means that the y, the y value is equal to 0. And the only way to solve for x is by factoring or using quadratic formula. Or if you'd like, you could use completing the square. So let's first see if we can factor this. The greatest common factor here is 2. So if we take the 2 out, that's leaving us with the x squared minus 4x plus 4. And then we can factor this portion as well. So for this portion, let's go ahead and see if we can make a diamond. We have positive 4 and negative 4. Oh, excuse me. So here we could say negative 2 times negative 2 is 4. Negative 2 plus negative 2 is negative 4. Because there's a 1 in front of the x squared, we can use our shortcut here and just go straight to our factorization, x minus 2 times x minus 2. So zero product property, these are the same factor, so we can just say x minus 2 must be equal to 0. X is equal to 2, so our root is at positive 2, 0.